Hey guys, is the mic working?
Yeah.
Okay, awesome. We are going to get started, and we're going to be going over DevOps and Docker today. Um, yeah, that's basically it. Oh yeah, so if you guys missed the last lecture, my name is Young. I'm going to be co-teaching with Megan for the remainder of the semester. Um, I taught this course for like the last 2 semesters. I was back in lead last semester. Megan's back in lead now. I'm team lead currently. And yeah, that's everything. Okay, great. So logistics. PA4 grades are out. The fifth assignment will be due April 7th due to spring break. And just a reminder that any extension should be asked for 24 hours in advance. Um, yeah, great. And coming up is the hack challenge, but like here are the rest of the lectures for the semester. We'll be going over authentication after spring break, then deployment, then hack challenge kickoff, and then the last lecture will be like a career and Q&A style thing. Just some more information on the hack challenge. I'm not sure if Megan has mentioned it at all during the semester. Basically, it's like, well, we have the 3 classes: design, iOS, and backend, and all the students from the 3 different classes, you guys will be like working in groups to work on sort of like a final project. And it's really cool because you get to work with people from the other disciplines. So you hopefully you'll get like an iOS app that connects to a backend that you write, while like designers designs for the front end as well. It's really about like integrating and kind of getting sort of like an app dev like experience, I think. Yeah. Does anyone have any questions about anything? Great. Okay, so same slides as last week. What can we do so far? Um, just like a refresher, we started out with data structures. Second assignment was like doing SQL through Python, and then last week we covered ORMs, and that's what the assignment was on last week. But this week we're going to be talking about something like pretty kind of like an aside from everything else we've been covering so far. So this is going to be a lot more theoretical rather than like, oh, we're going to follow along with a demo and learn a new concept. So we're going to be talking about DevOps today. Just out of curiosity, has anyone heard of this term before? Okay, gotcha. Okay, so don't worry, we're going to be going over it. So DevOps stands for like development and operations. It's like one of those like buzzwords in recent years that a lot of companies have been talking about. And we're going to be talking about why it's become a buzzword, sort of like what it actually is. And so, what is DevOps? I think I just Googled this and then I took the first thing off of like Stack Overflow. Um, but the definition was it aims at establishing a culture and environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. This might sound like a lot. It definitely is. But kind of like why it's important, right? So if we go back to the definition, um, it basically says like, oh, we want to get our software out as quickly as possible while ensuring that it's reliable. That's kind of my 2 cents on it. And kind of why it's important is because like in larger and larger organizations or even groups, right, it's increasingly difficult to push or release the code that you write. So for example, if I work on a project by myself in a class, I can just like write it myself and then submit it. I'm done. But if I'm like working with someone else, there are so many more steps, right? Like I have to go like, oh, what are you gonna work on? What am I gonna work on? We have to coordinate that. Like we're not overriding each other's code. We might use something like GitHub to make sure that like I don't know, we are updated on what the other person is doing, and even submissions is kind of difficult, right? Like you might have thought like, oh, this other person is going to implement it one way. Turns out they implement it a different way, and the code, like when it's combined, doesn't actually end up working. And this problem of scaling actually gets worse and worse the bigger and bigger companies or organizations get, right? And that's why this concept of DevOps, which we're going to talk even more about, is really important. So does anyone have any questions before we keep going? Awesome, nice, great. Okay, so yeah, so kind of adding on to the previous slide, it's important because we want to making the flow of like development as seamless as possible allows developers to be as productive as possible. And so I found this neat little diagram for DevOps. So on the left side is like developer stuff, and then on the right is like traditionally what was like operations tasks. So if we start like at the plan arrow, it goes from planning and then you create. So planning, will go into all the steps, I guess. But like planning might be like, oh, we'll release like an API spec. Creating is like, oh, I'm going to code it. Verifying it, something like the test cases, right? Like, oh, I'm going to make sure that my stuff works. And then the rest of the steps we haven't really talked about in the class. But that's like when you actually release your code, right? Like, how do you make sure that, like, if you deploy your code on a server, how do you make sure that your code isn't crashing, right? Like, how do you make sure, I don't know, that like clients are even able to connect to it, right? All of that kind of falls into the operations side. And then previously, when you had these two concepts sort of like, I don't know, separated from each other, it became difficult because like the developer might just, oh, be like, okay, I'm just gonna set up my code, and then as long as it works for me, it works for everyone. But then that might not be true when you actually deploy it. There are a lot of concerns that actually end up coming up. So some examples. So like the planning stage, it's mostly done by us for the assignments that you guys have been working on. So something like picking the language, right? Like these are all steps that happen before you ever start coding, like picking the language. So we chose Python. For databases, we chose SQLite out of some other alternatives like Postgres or MySQL. And one of the things that we chose for you guys is Docker, which we'll be talking about as well. For the creating step, this is the step where you're actually coding. So something like the API spec, right, helps with this. It basically gives you sort of like a baseline that you can base your code off of. And in terms of editors, this also helps you create faster. Imagine just like opening up Microsoft Word and then coding your assignment. It'd be really difficult to tell whether it was working or not. Editors make this process so much easier, right? You can create code more efficiently. You have stuff like autocomplete, linting. You can set up like custom key bindings to do exactly what you want and even more. The step after, verification. So how do you verify that the code that you wrote in the previous step actually works? So something like the API spec helps here, and then combining that with the test suite allows this process to basically happen as quickly as possible, right? So I think in the first iteration of this class, we actually didn't give a test suite, and then like we kept it internally for the core staff, and then it became really difficult for like students to tell whether their code was working or not, because it's really easy to like miss an edge case, right? Like, oh, this says return a list, but then you returned a dictionary, right? Those cases were really common, which is why we ended up releasing it. Okay, so yeah, so what about the rest of the steps? So that's where like this lecture and sort of the Docker component will come into this. So before we move forward, does anyone have any questions? Great, okay. So, okay, so we'll do a quick demo on virtual environment and sort of like, I think something to keep in mind is like, where does this actually fit into this stuff, into this life cycle, I guess. Okay, so let me just pull up my terminal. All right. Okay. Okay, great. So I have nothing in this directory. I'm just gonna make like an app file. So I'm gonna open it up in my editor. I'm just gonna call it app.py. And I'm going to just make like a really simple Flask app. I think it's from Flask, import Flask. And then I need to do some other stuff. Let me Google this really quickly. 1 second, sorry. Flask quick start. Great, perfect. Okay, perfect. It has everything I want. So I'm just gonna copy and paste that code in. So I mean, you guys should have it from your previous assignments. Just app equals Flask name, app route, and then we need the if name equals main stuff so that like when we run Python app.py, it actually runs. I think it's this, but we will find out. App.run, and then we set the host to be our computer, which is just 0.0.0.0, and then the port is 5000. Awesome. So pretty straightforward. I just copied it from the Flask website, and if I run it, it doesn't work, right? I mean, we already knew this error was coming, so we're going to set up a virtual environment. So the same syntax that you used before will also work for this. Hopefully this will actually run. I'm not sure if it ran, but we'll find out. Okay, let's see. So pip install Flask. Oh, lifesaver. Okay, great. So, so now if I run python app.py, something is using that port. That's not very good. Let me see what's going on. Right, okay. I'm just going to change the port because Megan informed me that the Docker VM uses port 5000. So when I run this, now I can go into my browser and then just open up localhost 3000 and then I see hello world. So, so if we think about this from a handoff perspective, now I can run pip freeze. So I can freeze my requirements into a requirements.txt. So we've seen this syntax before. If I just run pip freeze, I can see all of my dependencies. And then if I write this into a file, then if I print the contents of that file, I can just see that it's there. Something else that's nifty that you can do on Mac is like you can pip freeze and then send this into your clipboard. And then like if I run Command V, then I can paste it. That's actually unrelated. But anyways, okay, so moving on. So if you think about this from a handout perspective, I can just zip this, so I can delete this. And then maybe I'll just cd back and then zip the contents of that into like demo.zip folder, right? So if I move this back into the demo directory and then I cd back in, I have my zip file. So let's just delete app.py and requirements. So let's assume like, oh, I'm working on this with my partner and they just sent me the zip file. So now I unzip it and then now I cd back in and then I can install my requirements and then run the app, right? So I'm able to reproduce. So if you think about it, like I'm able to reproduce these steps. So like the packaging and releasing steps are what virtual environment actually ends up helping us with. And this basically allows us to have dependencies per project, right? So let's think about some of the benefits of using this. If I had a bunch of different Python apps, then, oh, my mic turned off? That's unlucky. Okay, I think it's dead. Sorry about that. I did not know. Okay. All right, is it back? Wait, did you guys hear anything I said? Okay, that's good. Okay, thank God. One sec. Yeah, so some of the benefits of using virtual env is that like if I had a bunch of different apps and they all had different requirements, then it would be a hassle because like if I ran pip freeze, I wouldn't know which dependencies corresponded to which application, right? And then so basically, oh, I know why this happened, sorry. Okay, but if I ran pip freeze and I was still in my virtual environment, it would tell me exactly what requirements I have for that project, and that way when I hand it off to someone else, they can just install the requirements that they need instead of everything. And one of the other things that it helps with is if we check that requirements file, sorry for the frequent switching, we can see that each of these packages actually has a specified version number. So this is really helpful because, for example, like packages are usually just hosted on GitHub, they're version controlled like everything else, and Jinja 2, like we're currently on version 2 of that, if I upgrade it to version 3, some features might be deprecated, right? And then, so if I told someone like, oh, install these packages, and they just pip installed it, they might not get the same versions I have, which might result in further errors. And yeah, so in the Devops cycle, this basically covers the packaging and sort of release cycle, release steps in this framework, I guess. So it allows me as a developer to package it and then just have that requirements file and then send it to someone else, which helps collaboration and releasing. So if we look at our current approach, let's say we were just installing it on a blank server, they'd have to install Python 3, they'd have to install the dependencies from requirements, they'd run the application, but then what about bigger applications, right? Like there isn't a virtual environment or a virtual env tool for every single thing. And so, oh yes, so some other questions that we might have is like, oh, what if we're using a database like SQLite, or like what if we want other custom package installs? And this is where I was gonna, oh, sorry, okay. So let's actually extend our Python app first to use SQLite, and then we'll go into Docker. So does anyone have any questions about anything so far? Does that make sense? So we use virtual env to help with those two steps. And even though like when you're developing, it might not make much sense because like, oh, I'm using Flask for all these projects. When you're actually doing handoff, it makes that process easier. Okay, so I think I posted some stuff on Piazza, so I'm just going to copy my own code in. So this is just from the last demo that Megan did. So I'm just going to copy this into my app file. So before I do that, I am going to move these files out because like I'm in demo/demo. So now I can get rid of this and also get rid of demo. Great. So if I open up my app file, I can copy in this demo code from the pin Piazza post right underneath the app declaration. So this should look pretty familiar. And then next up, we have a db.py file. So if I go back, I can just open up db.py in my editor. And I'm just going to copy and paste that code in and then just save it. So if I exit, now I have my app.py file and my db.py file. Okay, and there are some other packages I need to install. Let me find those. Sorry. Backend. Whoops, I'm just looking for the requirements file, sorry. Okay, sorry. And now I'm going to open up my requirements file and just change it to the ones from before. So if you did the most recent assignment or followed along in the last lecture, these should be the same one, or this should be the same one. Okay, so now I'm going to remake my virtual environment. So I've entered it. I'm going to install those requirements. Great, okay, so now I'm going to open up my app file, and we're just going to write some really basic routes. I guess this will just be like /tasks, so if I zoom out a little. So this is my db.py file, just as it's just a task class from last time. This will be just called get tasks. And I'm just going to return, or actually I'll just do like, all right, one second. I'm going to refer to Megan's demo. Okay, so tasks.query.all. So, great. Oh, also up top you need to do from db import db common task. And yeah, so query all the tasks and then just serialize them. And then the next route will be called just /add. So this will be really basic. It won't be as complex. Oh no, it's just... And we're going to make a new task. And this will have, I think it has description and done, I believe. But I'll just double check. Gotcha. Oops. db.session. So I'm going to commit the task to the... So I have to add the task and then I can commit it to the database and then I'll just return done or something. Okay, so now I have hopefully written some working code. I will now start my app. It looks like the table was created successfully. I'm going to go into my localhost browser, make sure that Hello World still works. It still works. It's good. This is a good start. Okay, adding also works. And tasks. Okay, this is not as good, but on the right. Sorry, okay, yeah. So I was just missing a import JSON here. So I'm just gonna add that. And hopefully now everything works. Okay, great. So we just extended our really simple app with some basic SQL features. And so now this actually ends up being more difficult to hand off, right? Because like now we have this added installation. So if someone were to try and reproduce this on like, they just got a new computer, or like we are trying to deploy our code to a server, for them to reproduce this, now there's more steps, right? They have to install Python, now they have to install SQL, Lite, and like as apps get more and more complicated, this process also gets more and more complicated. So does anyone have any questions before we go into Docker? Okay, awesome. Okay, so what is Docker? So Docker is a container platform that allows developers to package code into a standardized unit of software. So this also probably doesn't make any sense. I think the most important part of this definition is the standardized unit of software. So this is kind of what we want, right? We want to have some sort of like abstraction so that if we give someone else like a file, they are able to recreate exactly what we were doing to run it, right? So something like a requirements file works just for virtual environment and for Python packages. We don't have anything that encapsulates sort of like everything that we want in our application. And so Docker, if we go back, it defines itself as a container platform. We're going to get into exactly what that means. So Docker is split into images and containers, right? So images are a lightweight, standalone, executable package of software that basically includes everything that you need to run an application. And this includes stuff like the code that you write, runtimes. This might refer to, oh, like what version of Python are you running? What version of SQLite do you have installed on your computer? System tools, system libraries, these just refer to libraries like that come with your computer. Like Unix is based on C libraries, right? Yeah, okay. So, and containers are just running instances of images. So it's very important to have that distinction. So I'm just going to refer to them as images and containers. Here's something that might help you think of that analogy. So images to containers are like classes and objects in Java, right? Like you define a class in a file, and then an object is just like an instance of that. So if you have like a blueprint for a house, you can use that blueprint to make a lot of houses, and the houses are like the running blueprints, sort of, but not really. It's sort of the same thing, or like a recipe, and then when you have the cake, like the cake is the container, and the recipe is the image. It defines like how to make it, and the container is just like, oh, you actually did it. I'm not sure if that clears it up for anyone. Does anyone have any questions about that? Great. Great, great, great. So what's the difference between a container and a VM? You might look at this and be like, oh, this sounds so similar, right? It's actually pretty different, actually, like the underlying technology. So on the right-hand side, we have virtual machines. And so this might be like an Linux VM that you install on your computer so that you can follow along with this class, right? And what ends up happening is you download this like massive software, and it basically runs like Linux on top of your operating system. And so everything about the operating system is virtualized. So like even though my Mac might have Unix on it, right? Both of them are Unix operating systems. None of the C libraries get shared, and everything is just completely like isolated inside the virtual machine. However, on the left, Docker actually leverages the host operating system. So this is really nice because, for example, like on the right-hand side, if you're running 3 applications, this might be like the extent to which your computer can handle like the CPU usage or like the memory usage. But on the left, since it's leveraging the host operating system, it actually doesn't need to make a copy for every single application that you're running, and then you can run way more. Like my computer is super old, and I don't know, and it's still able to run tons of Docker containers. So it's actually really nice. So one of the other questions that you might have is like, okay, so if I have a VM and it's already virtualized, like I don't understand, why do I need to use Docker? So let's say we just use like VMs, right? Or like, let's just say, okay, we had everyone in the class install Python and SQLite, and then just let you guys deal with your own installation issues. But then this might actually end up being kind of tricky. We'd have to give like specific instructions for Mac and all like the Linux operating systems, or if you're trying to get it to work on Windows, we'd have to give instructions for those as well. Instead, as long as you have like this underlying software, Docker, we can just write one guide basically. So, oh, you have Docker running, then like it's going to be virtualized for us, and it's not going to be that much extra for your computer to handle. So it ends up being really convenient. Okay, so we're going to be going through some of the features and stuff that we talked about in Docker. So first, we're going to go through creating a Python image. So Docker has a lot of convenient properties that I think make it really straightforward to use. I'll just make a new directory in my demo thing called Docker, and I'm going to cd into it. I can just check that my Docker is running. I can run Docker. I get this. I also see like the whale logo in the top of my thing if I'm a Mac user. Great. So I'm going to open up a Docker file, and one sec. Let me find. I'm going to base it off of the VM one that we're using. So we'll just go through this line by line. I'm just going to copy and paste this. So we have from Ubuntu 1804. So if I actually Google like Docker Ubuntu images after my new, I'll just Google it here. Docker Ubuntu. Okay. Oh, this is super strange. Okay. I think it's my bad search engine that's causing these issues. So I'm just gonna Google it. Wow, amazing. I love Google. Okay, great. So I can open up Ubuntu, which is the image, like this is the image that we recommended people who use the VM use, and this is actually the Docker image that we base our like course Docker container off of as well. So we can see some Docker tags. So Ubuntu is the name of the image, colon denotes like, oh, I'm gonna have a tag name after this, and then we can see like 1804 is one of the tags here, right? So that's the image that we're starting from. From here, I'm going to run a command, so it's pretty straightforward. We start from an image and then we run a command. Run apt get install. So this is something that you would have had to do if you were on a VM, most likely to install Python. So something like this, right? So apt get install Python 3. So let's just see if this works. I actually don't think it's going to work, but we'll find out. So Docker build, and then I just specify I want to build in my current directory, which is just denoted by the dot symbol. So first it's pulling the image. So this gets pulled from Docker Hub, which is exactly like what this is, Docker Hub. And we're pulling this Ubuntu image with this specific tag. Okay, this actually might take a long time. This is unfortunate, but hopefully it'll complete soon. Oh yeah, what's up?
So what does the image contain? If like besides like the Python stuff?
Well, right now it doesn't actually contain anything. So we'll get into like how we would put our code into the image as well.
But then like what do you just like download?
Oh, what did I just download? Yeah. So if I look in the Docker file, this from image, so like Docker images are,
Like the library kind
yeah, so we're actually like starting from an image. So Docker files are actually like an image to image transformation. This is kind of what makes it really powerful. So for example, like I could build an image with Python installed and then tag it as like Python, right? And then I can start from that Python image and then like put my code in there and then have a completely different image, right? Does that make sense? So you can like constantly like stack stuff that you need. So if, oh, I just had a Python app, then I can start with this image that we're about to create. But then if I want to add SQLite, right, then I can start from the Python image and then just install
of.
SQLite.
So this, like that's like a base image kind of thing?
Exactly, yeah.
Uh,
And like you can start from any image that's available here. So like Ubuntu, Node.js, Python, they all have like official Docker images that you can start with and that they recommend. Yeah, what's up?
So if we're working in like a or we're doing all of our work in a Docker container, why are we also using virtual environment? Like, what does it not like keep all the dependencies correct without using virtual environment?
Right. Well, like, so Docker is meant to be used in sort of like addition to those other tools because Docker. Well, okay. So like one approach to doing this is like you could just install your requirements when you define the Docker image, right? But then that ends up being kind of cumbersome because like whenever you updated them, you'd have to update this as well. And then generally you want this to be kind of static, and then you want to just base your code off of this rather than having to update this every time. Yeah. Does anyone have any other questions? Okay, awesome. So we actually got this error. It said it couldn't locate this package. The reason for this is because we actually didn't run apt-get update, so this refreshes sort of like the package directory from Ubuntu. So now hopefully our code will work. So I'm going to just do the same thing. So if you guys didn't see, I just added this line, apt-get update, and then I'm just going to run build in the current directory. Yeah, so we'll get this huge mess, and this will actually take a minute, unfortunately. So basically what this does is if you start off with a clean Ubuntu install, it's very like lightweight. It doesn't come with any, so there's actually like a package directory, right? So whenever you run like, oh, I want to install this package, it refers to a directory that's kept on like these websites, right? Security.ubuntu, etc. And then it kind of gives like an official package listing so that you can install whatever you want. You can kind of think of it like the Mac App Store, right? It sort of keeps a listing of all the packages and where exactly to install them from. Okay, I got another error, not good. This one is because I didn't specify -y here. So it prompted me, and then I didn't say yes because I actually didn't get prompted. So hopefully this will be the last time we have to run this. Oh yeah, so if you didn't see, the only line I added was this -y. So if you see, so it's just this, if you're following along. Okay, great. So now it looks like it's working. It's reading the package lists that we just fetched. Hopefully it will find it and then install Python 3. Oh my god, didn't put the Y again. This is unlucky. Sorry. Okay. We'll put the Y this time. Okay, it has to come before the package name. Something to watch out for. Okay. This is the one. But one of the nice things of Docker that we see is like when you mess up building an image like I just did, it actually uses the cache so it doesn't run all the steps. So if you have like steps that take a long time, you can do some like really smart ordering of the steps so it doesn't actually run all these expensive operations over and over again. And this is really useful because like if you're trying to build a complicated image and you're like, oh my god, I just missed like the -y on the last step out of like 100 steps, you don't want to run the first 99 steps, right? And you might think like, oh, that's actually so intuitive. Like, why would anyone build it the other way? Some of the previous iterations or like tools that were similar to Docker, such as like Ansible or Chef, if you guys have heard of those, they actually didn't have built-in caching. It's like big headache actually. And hopefully, okay, great. So everything finally installed. So we have a Python Docker file. So like I mentioned, we can actually tag this image. So if I run Docker images, I can see all the images. Okay, this is not good. Well, we can see the newest one that I just built. So 22 seconds ago. The other ones are like, yeah, they're miscellaneous. Okay, so we have this, and then we can actually tag this. So we see that there isn't a tag here, but I can do that just by running docker build -t, and then I can tag this as like Python 3, I guess. Or Python 3 would conflict, but it's okay. And if you notice, like it notices all the steps are the same and then actually doesn't rebuild it. So that's amazing. Great. So we've just created a Python image. Next up, I'll just go to the next slide. We have Dockerizing our application. So this will answer the question of like, oh, how do we actually put our code in a Docker thing, in a Docker container, sorry. So if I go back into my previous directory, so I can actually make a new Docker file here. So that was just like a demonstration thing. And so now we're going to start from the image that we just created. So from Python 3. Okay, I'm actually not sure if this will work because Python 3 like is the name of a real image. That's not one I just made, but you know what? We'll find out. Okay, so I can actually copy all the files in my current directory into the home directory of my image. And then I can run, so now hopefully this will have Python 3 already installed. I can just run Python 3 install, wait, Python 3, pip3, pip Python 3 dash m pip. Okay, install requirements.txt. So we can actually just see if that works, if that chunk works. So the same thing, docker build dot. Okay, so if we notice like this hash actually matches this hash, so it was able to check it. This is not something that you should do because you never want to override like the built-ins of like the Docker Hub images. Yeah, I think that's it actually. We'll find out. So the reason why this copy step runs again is because we edited a file that was in the current directory, right? We edited the Docker file. Okay, I'll just install pip actually. So if I go into my Docker file, so I added apt-get install. This would be a mistake if I didn't put the Y, so I'm going to do that, and I'm going to rebuild my image. So this is actually good because like when you guys work on Dockerizing your applications for the hack challenge, you'll probably run into really similar errors, and like going through this will hopefully be helpful. And hopefully you guys will be like, wow, Young made this mistake. I better not. Okay. Oh, it's Python 3 dash pip. Okay, wow, how could I have guessed? All right, this is the time. This is the time. It's gonna work. Oh, okay, one of the other things to note. So this is more things that you want to avoid. If you see like this build context that we're putting in the Docker daemon thread is huge. And basically like that's because we're putting our VN folder and our PyCache folder. And so like we really want to avoid that, and I'll talk about how to not send all those files right after this hopefully finishes running. In the meantime, does anyone have any questions? Great. MB. It's part of the demo. In the meantime, just in case this doesn't finish, I will show you guys how you guys should do it. Let's just call this Dockerfile 2, which is actually, I don't even think that's going to work. But so actually there are Python images that you can pull from. So if I just Google Python, or inside of Docker Hub, sorry, I can just find the Python image and then see that, wow, look, Python offers all of these great images. So like if I wanted to run it on 3.7, I could just do 3.7 should be somewhere here. Well, all these are 3.7, but Yeah, so I could have just done that instead. Like I could have just done from Python 3.7, and then this would have actually worked and been a lot faster as well. And then this is what you guys should do. So in general, like you want to use the pre-built images as much as possible because like if you install everything yourself, it can take 5 minutes and then it might not complete. Yes, what's up?
So would that Python 3.7.1 already have like the Ubuntu on it probably?
Yeah, so these are also like, so they actually built these images the same way we just built our Python image.
Yeah.
So they refer to base images. So the Python images aren't like base images like the Ubuntu one is. Yeah.
Does the Ubuntu one have any like images? Is there like a basis image? Like
I don't think so. Yeah. But there are different like Ubuntu installations that you could base off of. Like for example, there's one called like Alpine, which is really lightweight, and then generally you want to use like lighter images so that the app, when you're running it on top of like your computer, takes up as little memory as possible. Okay, we're actually just going to cancel this and just run this one. Okay, so if I open up the Docker file, I can just do from Python 3.7, and this process will be much quicker. Wait, I'm not sure where I am actually. 1 second. Whoa. Where am I? Backend course? Oh, okay, I know where I am. Okay, sorry. So if I go into demo and then I open up the Docker file, I can just do from Python 3.6. I don't have to run this, and then I should just be able to run pip3 install my requirements. Oops. So it's going to be the same thing. It's actually just going to fetch the image, but it should be a lot quicker than me downloading pip myself. In the meantime, information, Docker Hub, the resource that we looked at, allows us to push images online. So this is something that we'll do right after we actually build our image. And hopefully we will get there in the Megan did. So kind of giving an overview of what that is like, I guess like a good example of it would be as a student, I take many classes and then classes have many students, right? So the relationship is on. Oh, okay. Okay, so can you guys all hear me? Great. So one example of a many-to-many relationship might be like students have many classes and then classes have many students. So the relationship is actually bidirectional, right? And this is really different from one-to-many relationships or one-to-one relationships in that you actually can't model the data like within the table, right? So if we have a students table and a classes table, the way that we did that previously was, oh, each student, if like, I don't know, if we had like one student, many students in one class, each of the students would have a class ID foreign key, right? And then that would allow us to kind of like model that. But then we actually can't do that with a many-to-many because if we add a foreign key on both of them, like it actually doesn't, will we have like a class for each of the students? Does that make sense? Like we wouldn't actually be able to do that. So what we have to do is create another table in our database that just models that relationship. And luckily for us, we'll be doing this with SQL Alchemy. There is a layer of abstraction, so we actually don't need to create a new table explicitly. We just need to say that, oh, we want to define a many-to-many relationship, and then SQL Alchemy will actually create that table for us. So the spec looks something like this. So it's exactly the example that I was just talking about. We have classes with IDs, code, like a name, and then you have assignments, students, and instructors. So like how you guys model this is really up to you. This is kind of like a preview of like what it will be like in the hack challenge when you work on it, because no one is going to give you guys a spec. Like you guys will come up with a spec and then give it to the iOS developers on your team, and then basically tell them like, oh, this is what it's going to look like on the back end, right? So this will hopefully give you guys more experience with that. Yeah, and the assignment will be out tonight. But just wanted to cover that. There's more links to resources for many-to-many relationships in the actual assignment itself. Does anyone have any questions about this before I check whether Python 3 finished downloading? No, awesome. Okay. Here we go. Okay, so now I think the error is I didn't actually run. It should just be pip install. And okay, hopefully we will build this in the 11 minutes we have left. Okay, so let's fix this error first. So I actually don't want to send all these files into Docker. So I can set up something that's called a Docker ignore. So it's just a .docker ignore. This is really similar to git ignore if you've used that before. And I can just put my VM folder, my virtual environment folder, and PyCache. Awesome. So I can build. And now you can just see that like I only sent my code in, right? Like 17 kilobytes compared to 14 megabytes. Wow, this is not a good day. I forgot the -r here. Um, oh yeah, it's up.
So how are pip and pip3 different?
How are pip and pip3 different? Yeah, so I think, well, pip3 generally refers to like the Python 3 pip installation. And that's like usually the case because on something like Mac, Python 2.7 actually comes pre-installed. And so there is like a necessity to distinguish between the Python versions. But then for something like this, where it's pre-built by Python, I'm assuming themselves, and like Python also wants to deprecate 2.7 completely, or Python 2 by 2020. And so it makes sense that they wouldn't call it pip3, it would just be called pip. Yeah. Does anyone have any other questions? Awesome. Okay, we're making progress. Okay, so now I can open up my Docker file. We're able to install our requirements. Now, hopefully, we can just do Python 3 app.py, or I think we can just do Python actually. Oh, okay. So there's actually one last thing. So when an image like kind of becomes a container, the thing that you specify, like the command that you say, oh, run this and then start the container, is defined by the special keyword CMD, and this just stands for command. It's special in that you can only have one of this keyword, and it has to be at the end of your Docker file. Does that make sense? So, like for example, I can have multiple run commands, but only one of this command, I guess. Okay. Okay, so we can actually fix this as well. So if you notice, like it's reinstalling the requirements. This is because in the previous step, this like cache. So this is just a hash of what the cache is, and you can see that it changed because I edited the Docker file. So one way to change this is I could just copy the requirements file into the image, pip install the requirements, and even if I change other files, the hash of the requirements file wouldn't have changed. So the entire hash actually wouldn't change either. Okay. Making progress. Remains to be seen whether this will work, but we'll find out. So now I can run this image by doing docker run, and I actually didn't tag it, so I can do that right now quickly. So docker build-t, I'll call this Python app, and then it should reuse the cache. So now this is really speedy, and now I can do docker run Python app. I'm going to specify some two flags here. So -it. So this is really common if you like look up, oh, how should I use Docker? And this basically says like if I input anything on my keyboard, like Control-C to get out of Docker, it'll actually run it inside of my terminal, and it'll let me Control-C out. So if I just ran docker run, didn't have these flags, and I tried Control-C'ing, nothing would happen, and then like I'd have to close this window, which would not be good. So we'll avoid that. So if I go to my localhost, it's actually not going to work. Great. Okay, something I planned for. Perfect. Okay, so the reason why this actually doesn't work is because if we think about it, this is running in sort of like inside of a virtual machine, and it's running on port 3000. But then that port 3000 is actually disconnected from my host port, right? So my host port 3000 has nothing to do with this port 3000. So actually we can specify this through a flag. It's pretty self-explanatory. -p for like port, and I can specify a mapping from port 3000 to 3000 on my computer. And now when I run this, and I go back here, and I refresh, I can see that, wow, it's actually amazing. I'm running something inside of Docker and it's like working on my computer, right? So this is sort of like why I think Docker is really cool, because especially when you go into like, or when you're trying to deploy something into production, like on an actual server so that other clients can use it, it's really frustrating to be like, oh, I don't understand how to install Python 3, or like I forgot the syntax and it takes me like 30 minutes to look it up, and then I miss like the -y and then it doesn't work, right? Like you can avoid all of that by just packaging your code into a Docker image, and then we'll go into uploading that on Docker Hub right now. And then when you go into your server, you can just pull that Docker image and run it, and then it's just that simple. And like your code that was running locally can just run on the server, right? So actually, we can. Should I demo that on a server or demo it uploading to Docker Hub?
Just uploading it.
Okay. So the way that you can upload it to Docker Hub, so it's like first you can go, if you just go on hub.docker.com. I already have an account. Wow, great. I think I did this demo before. But like, yeah, you can just register an account and then you get like a username, and then these are just tags, I believe, of that. Oh, sorry, yeah. So these are just repositories. So each of these has a tag associated with it. So if I click on one of these, there is a default tag actually that always gets added latest. So we can actually do that on my local computer. So once you sign up for an account, you can just do Docker login on your computer, and you'll be prompted for a username and password, and you can log in through your terminal. But then afterwards, you can tag your image. So I can do Docker-T, and then I can tag Python app as my username, and then like Python app. Sorry, it's not Docker-T, it's just Docker tag. And now it works. So now if I run Docker images, and then I scroll all the way up, I can see that I tagged my image, and these images have the same image ID, or the same hash basically. And now I can just do Docker push, and then the name, my username, and then the image I just created, which is Python app. Okay, and then like once that's done, oh, this will be cool. If you are running Docker on your computer, you can just do Docker run -p 3000:3000 -it, and then you should be able to run this on your computer, and then it should work, and you'll be able to do exactly what I just did, and like it'll run on your computer. But yeah, that's the cool part about Docker, I think. So like this works for any application, right? So like we actually use this on app dev for all of our own like backend applications, and then so we have like an organization like Cornell App Dev. All of our images are just hosted publicly. If I go to our repositories, and then this means that like all of our code is like kind of like built into here, right? So anyone can just pull this image. So like for us, like our deployment process, or how we actually run our code on the servers, is we just create a new server, and then we can just pull this image and then run it, like with syntax that's like very similar to this syntax, basically. Does anyone have any questions? Awesome. I think that is everything. Thank you guys for coming. And oh yeah, A5 will be due after spring break, or like the last Sunday of spring break. So yeah, get some rest and enjoy your time off, I guess. Yeah, that's everything. Thanks.